Hello aspirants, so welcome to Vision Institute. This is our quick bite series. We'll be discussing on the topic of redox reactions in today's class. So basically redox reactions is a mixture of red and ox, where red means reduction and ox means oxidation. So the reactions which undergoes reduction and oxidation simultaneously are known as redox reactions. So the reactions which is a sum up of reduction and oxidation is known as redox reaction. Reduction means gain of electrons and oxidation means loss of electrons. So redox reactions is been explained by two theory. Redox reaction is been explained by two theory. The first theory is classical theory, and the next theory is electron transfer theory. So according to classical theory, redox reactions are those reactions where addition of oxygen, oxidation, where addition of oxygen or electronegative groups is involved, whereas reduction means addition of hydrogen or addition of electropositive groups are involved. So in this redox reactions, basically we are going to discuss about classical theory as well as electron transfer theory, and we will also try to understand about the oxidation numbers, how redox reaction help us in calculating the oxidation number. So let us consider one example, and with the help of examples let us try to understand redox reaction. So suppose a reaction is occurring with Zn plus 2 in aqueous, will react with copper with solid and results in formation of Cu plus 2 aqueous and Zn solid. So suppose this is our reactions, and this reactions is the reactions called as Daniell cell reaction. This is our Daniell cell reaction. So here Zn plus 2, the charge on Zn plus 2 is been transferred to Zn0. So here the oxidation state of Zn is plus 2 and the oxidation state of Zn here is 0. So since the charges are being increased from plus 2 to 0, so since the oxidation number is increasing, so that is known as oxidation. While copper here the charge of copper is 0 and here the charge of copper is plus 2. So the difference in charge is from 0 to plus 2. That means here copper is undergoing increase, so that means it is reduction. So basically oxidation, and here in this reaction oxidation is happening as well as reduction is happening. So because of that reason only we will be considering this reaction as redox reactions. So here which theory is being applied? Here the electron transfer theory is being applied, because here transfer of electrons, gaining as well as losing of electron is happening. So since there is gaining and losing of electrons taking place, and because of that reason only it is called redox reactions. So according to classical theory, oxidation, as I told you, oxidation is nothing but addition of oxygen or electronegative groups. Now when we talk about electronegative groups in the periodic table, the most electronegative groups are group number 17. Group number 17s are considered to be the most electronegative groups of the periodic table, and these elements of group 17 are fluorine, chlorine, bromine and iodine. Okay, so if there is an addition, of electronegative group, that is fluorine, chlorine, bromine or iodine in the reaction, that means there is oxidation happening in that reaction. Simultaneously, okay, when I talk about addition of electropositive groups, so in periodic table the most electropositive group is group number 1, okay, and this group number 1 elements are hydrogen, lithium, sodium, potassium, rubidium, cesium and francium. Okay, so when there is addition of any of these elements, okay, taking place in the reactions, okay, then basically it is reduction. Or I can also say that if there is removal of electronegative group, okay, then it is also reduction. So basically oxidation is addition of oxygen or addition of electronegative group, whereas reduction is removal of oxygen or removal of electronegative group. Or vice versa, I can say that reduction is addition of, okay, hydrogen or addition of electropositive group, or I can say removal of oxygen or removal of electronegative groups, that is also reduction. So let's try to understand this with the help of one more example. Redox reaction ka let's try to understand with the help of one more example. So suppose aluminium, okay, aluminium solid is reacting with Zn plus 2 aqueous, and it is been converted to Al plus 3 aqueous plus Zn solid. Okay, so in this reaction, see, aluminium is having a charge of 0, okay, and here the aluminium is bearing a charge of plus 3. So here oxidation number, okay, is increasing from 0 to plus 3. The charge has been increasing, right? So that's why it will be called as oxidation. Okay, and here Zn plus 2 is bearing a charge of, okay, Zn is bearing a charge of plus 2, and here when I see on the product side, Zn is bearing a charge of 0. Okay, so here the difference of charge is again plus 2. Okay, the difference of charge is plus 2, but see here in the reactant side the charge is plus 2 and in the product side the charge is 0. So that means the charge is decreasing, so that means our oxidation number is decreasing, and because of that reason we call it as reduction. So that means in this reaction oxidation and reduction is simultaneously occurring. That means this is also an example of redox reactions. Okay, now let's try to balance this reaction. Since the charge difference is since there is difference in the charge, so we need to balance out the reactions, because here aluminium is undergoing oxidation. That means aluminiums are being oxidized to Al plus 3, whereas zincs are being reduced from Zn plus 2 to Zn. That means here the difference in the charge is, see, here the charge difference is plus 3 and here the charge difference is plus 2. That means it is not balanced. So how can we balance it out? If I multiply here by 3 and here by 2, that means the difference of charge will be 6. Okay, 6. That means the value of N will be 6 here, where N indicates number of electrons gaining or number of electrons loss. Okay, that means it's reduction or oxidation only. And if I'm multiplying here by 2, that means this 2 has to be multiplied with aluminium, as well as it has to be multiplied with aluminium 3 plus. And if I'm multiplying here by 3, that means this 3 has to be multiplied with this zinc, and it has to be multiplied with this zinc also 3. Okay, in this way we can balance out the reactions. Okay, students, now see, if I have to write this cell representation of the reactions, if I have to note down the cell representation of this particular reactions, so how can we do it? Okay, since aluminium is been oxidized to aluminium plus 3 and zinc plus 2 is been reduced to Zn, okay, so that means I can say anode, okay, slash that is always by cathode, right? Okay, so that means here anode means oxidation, and cathode means reduction. So that means first I have to write down anode का representation, that means oxidation का representation, and then only I'll be able to connect this with the reduction representations, reduction का representation. So that means aluminium, okay, aluminium solid will be converted to aluminium plus 3 aqueous, and they will be connected with the help of salt bridge with Zn plus 2 to Zn solid. So this will be the representations of our redox reaction in terms of cell representations, or we can say cell notations. So experience, this is all about redox reactions. So for more videos, please stay with us, and we'll be providing the videos from time to time, okay, and you can find the videos in our Vision Institute channel. So for more videos, please stay tuned with us. Thank you.